Chapter 1.4.1.6 Pod Quality of Service Classes. This page discusses quality of service, QoS classes in Kubernetes, and how they are assigned to pods based on resource constraints set for containers within the pod. Kubernetes uses these classes to determine which pods to evict in cases of resource scarcity on a node. The classification system helps prioritize resource allocation and ensure efficient utilization of available resources within a Kubernetes cluster. Quality of service classes. Kubernetes assigns pods into specific quality of service QoS classes based on their resource requests and limits. The three possible QoS classes are guaranteed, burstable, and best effort. Guaranteed pods have strict resource limits and are least likely to be evicted, as they are only removed when exceeding their limits or if lower priority pods can be preempted. To be classified as guaranteed, each container in the pod must have both memory and CPU limits that equal their requests. Burstable pods have some resource guarantees but do not require specific limits, allowing them to flexibly increase resources if available. They are only evicted after best effort pods. To be classified as burstable, at least one container in the pod must have a memory or CPU request or limit that doesn't meet the criteria for guaranteed. Best effort pods can utilize node resources not assigned to other QoS classes. They are preferred for eviction under resource pressure and are classified as best effort if none of the containers have memory or CPU limits or requests that meet the criteria for guaranteed or burstable. Pods in the best effort class can request other resources beyond CPU and memory. Overall, Kubernetes uses QoS classes to determine which pods to evict from a node under pressure, with guaranteed pods being the most secure in terms of resource limits, followed by burstable and best effort pods. By understanding the criteria for each QoS class, users can optimize resource management within their Kubernetes environment. Memory QoS with cgroup v2. In Kubernetes v1.22 alpha, memory QoS is utilized to guarantee memory resources by using the memory controller of cgroup v2. Memory requests and limits of containers in a pod set specific interfaces such as memory.min and memory.high. By setting memory.min to memory requests, resources are reserved and not reclaimed by the kernel, ensuring memory availability. Memory limits set in containers are used to throttle workload approaching memory limits, preventing overwhelming system memory allocation. Memory QoS relies on QoS class to determine which settings to apply for quality of service control. Some behavior is independent of QoS class. Certain behavior in Kubernetes is not dependent on the quality of service QoS class assigned to a container. For example, if a container exceeds its resource limit, it will be killed and restarted by kubelet without affecting other containers in the same pod. If a container exceeds its resource request and the node faces resource pressure, the entire pod may be evicted and terminated. The kube scheduler does not consider QoS class when selecting pods to preempt, meaning preemption can happen when there are not enough resources to run all defined pods in the cluster.